Hi, everyone. I'm Eron Wright. I work for Dell EMC, and we've taken a real interest in Apache Mesos and, of course, Apache Flink. We love Flink, and we want to see the two work well together. So first question I have for the room, who here uses Mesos today? I see one hand. So who here is familiar with Mesos? Okay, that's great. Well, I'll just say a few words about why Mesos is interesting, and then we'll get into the work we're doing to integrate Flink with Mesos. So you've probably used Yarn before. You've probably deployed Flink to Yarn. And Mesos is similar to Yarn. But Mesos is really exciting as a larger scale data center operations system. It's an operating system for your data center. And it comes in both an open source and various closed source forms. It has some really cool capabilities for services well beyond what you can do with Yarn. In particular, it's great for storage services. And that's because Mesos contemplates not only CPU and memory, but also contemplates disks. So with a Mesos environment today, you get so let's say you deploy Mesos first into your data center, set it all up. You can then, with ease, deploy services like Kafka, Flink, HDFS, Cassandra, Hadoop. So you can deploy things into a Mesos environment, and Mesos will manage the resources of that environment in sort of a converged way. So what we want to do is introduce support for Mesos into Flink. One thing about Mesos to know is that it's an Apache project, right? But it is not the whole solution. You need a lot of supporting services around it to do DNS stuff. There are something called Marathon, which most people probably know, which is like an init system for services you run on Mesos. So there's actually a distribution of Mesos called DCOS, and that's an open source distribution that embodies a bunch of best practices around Mesos. So what we're trying to do when we integrate Flink into Mesos is actually observe those best practices, and you'll see some of that as I go through the talk. It makes a lot of sense to run Flink on Mesos. You've probably used Flink's standalone mode before. But Flink standalone lacks a lot of the sophisticated scheduling that you expect from a system like Mesos or Yarn. And it's the Flink, the discussion now is that we'd rather keep advanced scheduling out of Flink's core and instead delegate that scheduling logic to the cluster manager, whether it's Mesos or Yarn. And those schedulers do a lot of work for you. For example, Mesos has support for quotas, has multi-user support, so it can do various forms of fair scheduling and whatnot. And that's well beyond what you can get out of the Flink standalone. Another thing is, if you stay for the security talk that comes after, you'll see that security enhancements that are going into Flink now are really at the cluster scope, not at the job scope, meaning the credentials and whatnot that you have to access, secure data sources, for example, those credentials are really are available to every job that runs in a given Flink cluster. And so rather than trying to scale up a Flink cluster, it's better to have many Flink clusters and for them to be job specific. So in that way, each cluster can have its own credentials, can have its own scale, etc. And the only way to get that outcome where you have many Flink clusters running is to use a cluster manager like Mesos or Yarn. Flink, though it's not a storage service, it does take advantage of temp space and can really benefit from the disk resources of Mesos. That's one. Two, Flink's elasticity is improving. You probably maybe heard in the other talks here yesterday that there's this whole notion of dynamic resources coming to Flink, where even through the life of a job, Flink will scale up and down as per the needs of the job. So those kinds of capabilities are best supported by using a cluster manager like Mesos. Now I'm going to jump right into a demo, and I'm going to show you something that's fairly familiar. I'm going to do what is the analog to yarn session. Who here has used the yarn session command in Flink? Awesome. Okay, you're going to see something just like that, but this time it's going to be with Mesos. And then we'll kind of work backwards at what has gone on in the course of launching that session and running a job against it. Okay. Can everyone read that? Okay, so here I am at my Flink distribution, and I'm going to use, I'm going to do, oh, haha, hilarious. So let's start a Mesos session. And what a session is a synonym for a Flink cluster. So when we run this command, what we see is an ordinary Flink cluster has been deployed into Mesos. And so let's go into the Mesos UI. And what we'll see is 2 tasks have been deployed. You'll see there, one is the job manager task, and the other is the task manager task. And this together corresponds to a simple Flink cluster, right, of a typical job manager, task manager combination, right? So given that, you can see this Mesos session kind of pops out some hints about how to run a job against this. And because some of this is still a work in progress and won't really be ready until we hope Flink 1.2, you're seeing some things that aren't totally polished. So this is a simple way to run to try out this cluster, and let's do that. First, I'm just going to go to the Flink session. And I'm going to spawn its Flink UI. All right. So again, we see a Flink cluster running. We see a single task manager running. And let's just go and run a job. All right, word count for the win. We just ran our first Flink job on a Mesos cluster, and you can see that just works, normally. So what I'd like to do now is talk to you a little bit about what we're seeing under the covers, a little bit about how it works, and I'll be looking at some of the logs that show up here as we go along. There are 2 major components to this solution. The first you know really well, that's the job manager. But in a Yarn or a Mesos context, sometimes we call it an application master, or in this case, it's referred to as the Flink master process. The master process is the process that hosts the job manager, hosts a component called the resource manager, and hosts some supplementary services like a small HTTP server that I'll talk about more in a minute. This master server, during this exposition, isn't necessarily running in Mesos. But it acts as what's called a Mesos framework. A framework means a Mesos program, and all Mesos frameworks, they implement or they use a protocol to speak to Mesos, and then Mesos will make the framework offers of resources. So let's imagine this as being a small Mesos cluster here, and you see I've got 8 slots, so to speak, across these 2 hosts. And what has happened in this diagram is that the master has interacted with Mesos as a framework, has been offered some resources, and has proceeded to spawn 2 task managers into the cluster. Right? So the master is a Mesos framework. He's responsible for all of the scaling and recovery and oversight of the task manager. That's his job. And as I say, this is all in the scope of one Flink cluster. Right? So if we were to have many Flink clusters running concurrently, we would expect to see a master plus some number of task managers for each and every cluster. Digging in a little bit deeper, let's talk about how the master works. There's sort of a multi-step process. First, the master registers as a Mesos framework, and Mesos provides the master a framework ID. The master then begins to receive resource offers. These offers come over time. So at a steady state, as resources free within the Mesos cluster, Mesos uses a really simple but surprisingly effective form of cooperative multitasking. What it does is, for any resources that come free, it broadcasts these these offers to multiple frameworks that may be in the system. So let's say you had Flink running, you had some other things running. All of those could potentially receive offers of free resources, and these frameworks will compete as to who actually acquires the resources. The general idea, of course, is that when an application is at a steady state, it probably doesn't need resources, and so it just quietly declines those offers, and they go on to be offered to other parties. It's surprisingly simple but effective, but that's the Mesos way. So over time, this master receives resource offers from Mesos. And meanwhile, the job manager in Flink, which is cognizant of jobs that are running inside the cluster and their resource requirements, the job manager interacts with this component to create what we call task requests. Task requests need to be compared against the offers that are coming from Mesos. And then that culminates in some new task launches. So within there is actually a knapsack packing problem. Okay? And it's one of the most interesting and hard aspects of writing Mesos frameworks, is that on one hand, you've got some offers of resources, and you've got some tasks that you want to launch, to fulfill. And these offers can come in many different forms. So, for example, if resources are available across 2 hosts, you'll receive multiple offers. One offer from host 1, an offer from host 2. As well, offers can be highly fragmented. So if you think of this as being like each of these boxes being like a gigabyte of RAM, maybe, you could receive 3 offers from this host, each of a gigabyte of RAM, or you might just get 1 offer with 3 gigabytes. So it's a packing problem where you have to figure out what is the optimal use of these offers given the outstanding tasks that I have. As well, you could be trying to fulfill one or more optimization objectives. So maybe our objective is to just get as much memory as we can on the fewest number of hosts. Or maybe our objective is, well, we would like to get tasks that are really close to that Kafka broker. Or maybe we'd like to have tasks that are spread across racks. There's actually many different objectives you might be solving for. And so we decided to use a library from Netflix called Netflix Fenzo. Fenzo is a really cool optimization library, and it can solve a knapsack problem with various optimization objectives, with what we call fitness evaluators, which give you a lot of knobs to turn to get the right to accept the right offers and to get tasks placed in the way that you need them. Putting this optimizer in place, which I sort of depict as step 3 here, where we get those offers. Again, we've got outstanding scale requests from the job manager, and then we're optimizing to find the optimal placement. Putting that optimizer in place is a big part of being able to do the dynamic scaling that Flink will have in the coming months. You can imagine how a streaming job versus a batch job could have very different objectives or very different needs. Similarly, a streaming job that maybe is experiencing lag, or maybe has just started and has a lot of catch-up work to do from some Kafka topic, may need to acquire tasks for doing that back processing and then ultimately relinquish those tasks once it reaches a steady state. So a lot of that dynamic behavior is coming, and having an optimization library like Fenzo in place was a big sort of strategic decision to empower some of that. So given that optimization that goes on, we eventually can launch task managers. Of course, the master's main job is to monitor these at a steady state and recover them as necessary. So eventually, these task managers could fail, and the job manager or master will detect that, will create replacements, etc. So whether it's due to like a planned or an unplanned event that leads to the loss of a task manager, that recovery is responsibility of this master. Just to point out one additional detail about how Mesos works, these task managers run inside what's called a sandbox. And the sandbox is the local directory of files that the task, which is a process, has to work with. Pardon me?
Is this a change root?
It is, yes. His question was, is this a change root environment? And I might phrase that as, is there containerization in use in Mesos? And the answer is definitely yes. Mesos has a plugin model for what they call isolators and containerizers that do take advantage of Linux C groups, for example, that can take advantage of Docker images to create an alternate file system view for the task. So there's actually a lot of power there in getting exactly the file system that you need and the isolation you need between tasks. So if I just go to my Mesos environment here, I'll actually show you. I'll show you the sandbox for one of these tasks. You can see the task manager that we. Oh, sorry, guys. Sorry, everyone. There we go. So you'll see this, for this particular task, a bunch of files have been populated in its sandbox directory. And this is very, very similar to how Flink on Yarn works. Basically, these files are shipped from the client up into the cluster from your local installation of Flink. So for example, the Flink jar file, supporting files, including log4j configuration, the Flink configuration, all of that makes its way into this sandbox, and that's sort of a local structure that the tasks draw from. All right. So let me just show you briefly how you configure this to really work. So this is the standard Flink configuration file, and most of the settings are just the typical ones, but there are some new settings for Mesos. In particular, you need to tell Flink where to find the Mesos master. This is, there's sort of a well-known format to these master connection strings, if you will. They can take a direct IP address, but as is common with other Mesos frameworks, this can also be a zookeeper entry. This can be like a ZK scheme. And in that case, it will use zookeeper to find the Mesos master in a highly available way. So you configure where is Mesos. You configure some settings to do with the framework name and whatnot. And on my slide, I'll show you more of them. And I'll talk about that other one in a minute. Yeah. So these are standard settings that most Mesos frameworks support. For example, the secret and principal are essentially the username and password one is using to authenticate against Mesos itself. Mesos frameworks can authenticate themselves because you can lock down your Mesos cluster to some degree, and you can even you can get into things like quota, so that maybe user number one can't use up all the resources of the cluster. He's maybe this user's given me 50% of the cluster, and another user's another 50%, stuff like that, and authenticating against Mesos, and then using what's called the role, which is like the project name, if you will, that has been associated with that user in my example. These are the things you need to get those effects. All right. So I talked to you about the master process, but there's a lot more going on here. One of the differences between Mesos and Yarn is that the application master in Yarn is something that the client launches into Yarn, and then Yarn runs the application master and all of its associated tasks. And if the master quits in a Yarn scenario, Yarn will restart the master automatically. But that's not the case in Mesos. In Mesos, the framework that is in this case, this was our master here. That framework that interacts with Mesos doesn't need to be running inside Mesos, but it can be. And we want it to be because we want the entire Flink session to be running in Mesos. And so to enable both the master and, in this case, the job manager, if you will, and the task managers to both be running in Mesos, and indeed to have potentially multiple Flink clusters running independently, all running up in your cluster, you need another component to act as sort of the init system for those clusters. And that component we call the dispatcher. If anyone saw yesterday's talk from Stefan, he talked about in the Run Things Anywhere. Did anyone go to that talk? Yeah, you probably saw he talked a lot about this so-called dispatcher. That's under an umbrella project called Flip6. This is a part of that, or this is aligned with that. And so that same dispatcher he's talking about is what we're talking about here, only we're developing it in an early form for Mesos purposes. So what this dispatcher does, as I say, is it provides sort of a front door to be able to launch Flink clusters. And it launches these clusters and is primarily only responsible for really the masters. It launches the master, and then the master launches the tasks. So in fact, what you get is this really cool but very common pattern in Mesos, where you have a sort of nested hierarchy of frameworks. You've probably seen this if you've used Mesos yourself or read about it, that Marathon is a Mesos framework and launches things into the cluster as tasks. Well, chances are you're going to want to launch the dispatcher in a nice permanent way into your cluster, so it'll probably be launched by something like Marathon. Now, that dispatcher is a framework, and it wants to launch things, in this case, the Flink cluster, one or more. So The master process of that cluster is actually a task of the dispatcher. That master is a Mesos framework. And so it launches tasks that are the task managers. And so we get this sort of nice waterfall of tasks sort of supporting each other at different levels of detail. Oh, that is a great question. I'll repeat the question. When is the dispatcher launched? Well, there are a few different modalities that we'd like to support. The primary form, and I'll cover that in this slide actually. I'll go back to it. The primary mode of use that is envisioned is one where the dispatcher is something you launch up front into your Mesos cluster, and it provides an HTTP gateway or endpoint that the command line can use to spawn Flink clusters. When you ask it to spawn a cluster, it does so by launching a master process accordingly, and then that process proceeds to launch task managers. But it could also be, in some scenarios, like, for example, the Flink shell, where it's overkill to have to run this dispatcher. And so most of the logic that is in the dispatcher has to do with acting as a framework and launching Mesos clusters or sessions. And so the dispatcher will probably be hosted in both of these two modalities. So in sort of a local mode, when you run the CLI, say, for example, Mesos session command, you can choose to have the dispatcher launch embedded within it. And in that case, you don't need to have that Mesos infrastructure, or don't need to have the dispatcher permanently running in Mesos. But to be clear, the reason why this is not the only solution or even the best solution is because this client would have to stay connected to the network for the dispatcher and these tasks to survive. If this link were to be severed, like let's say you close your laptop, then Mesos will kill these eventually because there's no framework defending them. So this is why we need this sort of structure to create this detached mode where the CLI can spawn a cluster and then can disconnect, and this dispatcher will manage that cluster on your behalf. Does that answer your question?
Not completely, because in remote mode, is the dispatcher pre-launched by America? Or
Yes.
so this dispatcher is always available, waiting for the next client to start the Flink cluster.
That's right.
Yeah, but the dispatcher is Flink specific.
Yes.
Yes. So that means that Mesos must keep the dispatchers from Flink, Spark, Sandra, or Kafka all available in the cluster in case some client comes to launch a Flink job, to launch a Cassandra, to launch Kafka, or whatever.
That is right.
That makes many dispatchers inside the cluster, which possibly don't do anything.
Well, I would argue they do something, but I agree that.
Yeah. But that's what the question is. Are they starting on demand, or are they always maybe there to work close?
I will say that this architecture isn't necessarily what you would find in other Mesos services like Kafka or Cassandra or HDFS. Well, yes, and the reason this is done like this is to support bringing up and down Flink clusters over time in a very on-demand kind of way, right? And that's part of that theme where Flink clusters are becoming increasingly elastic to the point where, are aligned with the life cycle of a job. So when you have a Flink job, you send it to the dispatcher, it launches a cluster at some scale to support that job. And once the job quits, like let's say this is a batch job, by the time the job quits, the Flink cluster can disappear, and you're left only with that resident dispatcher.
Yeah. So if I imagine this as a dashboard, when I start Flink in the dashboard, it just starts the dispatcher to be available to accept requests from the client to launch the cluster.
Yes, the question is, as the dispatcher is really the top level service here. So if you go, as was mentioned, if you go to the DCOS or Marathon user interface, what you'll see is the Flink dispatcher running as a top level perpetual service. Now that service is not a cluster. That service is the dispatcher exposing our REST API, enabling you to launch Flink clusters on demand as you have jobs that need execution.
Now it's good. Thank you.
My pleasure. So just a word or two about how this works. It's very similar to what we just saw with how the master works with respect to the task manager. In more or less the same way, the dispatcher has to manage the masters, right? Both these services are highly available. And so they use Zookeeper to persist the necessary state to be able to do recovery and whatnot. It's really the dispatcher that acts as a bridge, if you will, between the CLI spawning a job and or a session today, and supplying the necessary ship files, supporting libraries and whatnot to be able to launch these clusters. So there's a bunch of future work yet to be done. I'm just going to mention some of these. You've heard a lot about dynamic scaling. This is about being able to, within the life of a job, grow and shrink a Flink cluster. That's one of the most exciting things that could be done in the next year. As I said, some of that optimizer stuff is supporting that. The dispatcher itself is part of a grander project that's referred to as Flip 6 and was mentioned yesterday. The dispatcher is going to become where the web UI resides, as opposed to the web UI running along with each job manager. So the web UI is thought to, we hope will evolve into something that is pan cluster, meaning it can contemplate many clusters and provide a historical component. So seeing job history well after the resources associated with that job are gone. So that dispatcher is becoming kind of a central point for some of that stuff, as well as for authentication support, so that eventually you can ask the dispatcher to launch a job maybe on behalf of something, and it could act in sort of a proxy user type of things in a manner similar to Hadoop. Docker image support is a minor but important feature to be added here, so that when you launch a Flink cluster, you can supply a Docker image. And then if you have native libraries associated with your cluster, like a Blaz library or something, you can get that along for the ride. And finally, adding disk support. We will greatly increase we'll scale up a Flink cluster tremendously if we can give it more spindles. And so we can acquire local disk from Mesos with some additional programming. But the main limitation right now is that Netflix Fenzo doesn't have adequate support for what's called reservation, which is an aspect of getting local disk. So there's some contribution work yet to be done to Fenzo, and then we can add disk support into this as well. Finally, this is hopefully going to be ready for Flink 1.2. Myself and Max have been working on the code for some time. You can check out the code as it is right now. Some of it is actually already in master today, but the code that is still a work in progress is the dispatcher code. And it's being all done under auspiciously named Flink Jira. So thank you, and with that, any questions? Hi.
Which version of Mesos is this targeting?
The feature set since we don't have disk support yet, is not that high. So in concept, we could backport it to earlier versions, but it was developed under 0.28. And I would say that from a support perspective, we might well say 1.0 might be even, because 1.01 is out now. So it'll be only a partly recent one from a support perspective. Does that fit with your need, or do you have an earlier version you care about? Good. Not that I know of. Not that I know of. Yes?
Yeah, quick question. So first of all, the Netflix sensor, did I understand it right, that it takes care of the locality of the deploying cluster?
Yes, it can. It can. And what I mean by that is that you specify both hard and soft constraints when you program the optimizer. So if you had hints from the job manager about where the ideal location for a new task manager might be, you can use those hints down in Fenzo in the form of soft constraints. So there's a lot of knobs there that can be turned in the fullness of time.
The question was, do you have like remote user support? Do you have some sort of fairness in mind, or how do you distribute resources across multiple jobs, or is that everybody has to decide?
I'll repeat the question. The question was, what is, again, this multi-user sort of fairness story? And the answer really is we want to delegate that to the cluster manager, in this case, Mesos. So if you've got two jobs, that is realized as two separate Mesos frameworks, two wholly separate set of task managers, each running at their own scale. So user 1 has some small scale job, user 2 has some large scale job. They're isolated thanks to Mesos's isolation and fairness and other scheduling magic. Hi.
Yeah, question. So first of all, pretty cool the way this is evolving into a really architecture. So you're not using Mesos for automatic code, how do you see this compared to Kubernetes?
Well, that's a great question. Yes, the question was, how do you compare this to something like Kubernetes? My take is that I really like how Mesos is aligned with the Apache big data stack. So number one, both Spark and now Flink have native support for it. And these applications, but whether it's Spark or Flink or other things, because of how it integrates programmatically, right? You actually write that framework code to talk to Mesos, you can get a lot of nifty effects, like all that dynamic stuff is possible. So if we see, for example, a topic is lagging, we can scale up a cluster, right? Those things are not as easy in Kubernetes because all of that is external from Flink's perspective. And from Flink's perspective, it just is given some number of containers. And you would need to use like an external scaling component to get those same effects. And so I love the intimacy that a framework has with something like Mesos or Yarn as compared to Kubernetes. Yeah, it's a deeper, more integrated system, and so you can get that kind of elasticity that is not as easy to realize in something like Kubernetes. And the other thing about Mesos is that it has disk resource support. And so from the point of view of storage services, which is something that Dell EMC knows and cares a lot about, it's a very exciting way to deploy these services because in things like Kubernetes, there's no real disk support. It's all kind of thought of as ephemeral services. Correct me if I'm wrong, if they've added that since then. Any other questions? Hi. I would say more the latter than the former. What Mesos offers are local disks. So it's not offering protected storage or network storage. What Mesos offers natively is local disk resources similar to local memory and CPU resources. But a storage service like HDFS can be deployed on Mesos, and HDFS uses those local disks to create a distributed file system. And that's the persistent way to store save points or what have you. And when I say HDFS, I could mean any storage system you deploy, even one that Dell EMC would tell you. That's right. That's right. Though his question, I think, is about what's the life cycle of local disks in Mesos, and that is something that the Mesos team cared a lot about, and they view them as a kind of long-lived allocation. And so there is a reservation procedure that goes on where a framework actually reserves the disks, creates volumes against it, and then it has to explicitly release it, even if that framework has like gone offline. So you could power cycle the whole thing, and you'd still have those disks. All right, well, thanks everyone for attending.